Hello, my name is Peter Wolecki, and today I'm going to be talking about the Sunrise Optical LLC endpoint detection product line. We are a company based in Florida, and we specialize in the manufacture of optical metrology systems. The main features of the EPD system include an exceptionally strong signal-to-noise ratio, mainly because of superior optical data collection methods. The system is also immune to stray light and vibrations, meaning that you can perform measurements in ambient light without any impact on data quality. Also, vibration isolation tables are not required for this system. Furthermore, there are no lasers used in the system, meaning that the system is completely eye-safe. The system is also completely silent as there are no moving parts present. Furthermore, the system is also highly customizable, meaning that we can custom tailor a solution to your metrology requirements. This flowchart is a general overview of the unit itself. The system works by shining a controlled light source onto the sample and then measures the returning signal using the specialized detector system. The signal is then conditioned and analyzed by the unit. Typical data acquisition time is around 0.1 seconds. The whole operation is controlled through a standard USB cable, which is then connected to a PC system. On this slide, we have a chart which demonstrates the performance of the system when the sample is exposed to a number of different light sources. From left to right, the sources are no lamp. Then we have a 15-watt fluorescent bulb at 20 inches away from the wafer. Then the same 15-watt fluorescent bulb at 40 inches. Then we have a 40-watt incandescent bulb at 20 inches away from the wafer. And then finally we have a 40-watt incandescent bulb again at 40 inches away from the wafer. As you can see, the system is immune to stray light from a number of different sources. This slide shows a chart which demonstrates the noise of the system when the sample is exposed to the same light sources as in the previous slide. Again, from left to right, the light sources are first, no lamp, then we have the 15-watt fluorescent bulb at 20 inches, and the same 15-watt fluorescent bulb at 40 inches away from the wafer. Then we have a 40-watt incandescent bulb at 20 inches away. And finally, we have a 40-watt incandescent bulb at 40 inches away. The system only experienced a very small increase in noise when presented with a very strong stray light source. This slide lists some specifications of the system itself. As you can see, we have a number of LED colors. These colors can be customized upon request in order to measure different samples more efficiently. The modulation frequency of the light source is around 500 Hz, which can also be changed upon request. Acquisition time is around 0.1 seconds, and we can go down to 0.01 seconds if required. And we have a number of different available gains, and around 20 to 60 decibels of dynamic reserve depending on the settings of the system. On this slide, we have a list of the main endpoint detection system features. First, we have superior stray light rejection. Our light source is completely eye-safe as we do not employ the use of any lasers. There are no moving parts. The estimated time to failure is around 50,000 hours, meaning that we do not foresee the need for any service required. The system is completely silent as it does not require a fan. The optics are robust. And the same system can be used for a variety of different measurement techniques. On this slide, we saw a typical wet etch application. The system works by shining a beam of light onto the wafers during the etching process and monitors returning signal during the etch so that the wafers can be extracted just at the moment when the right amount of material has been etched away from the wafers itself. The system works on many different types of wafers, including those with exceptionally large dies. We also specialize in designing systems for extremely difficult measurements, such as those where the working distance changes during the measurement, or when the sample itself moves during the measurement. In the past, the end user would have to employ guesswork and trial and error in order to determine which wavelength would be the optimum wavelength to improve the signal-to-noise ratio for their system. Now, we don't require this guessing because we developed a piece of software which allows the end user to select which materials his sample is made of, and then the software calculates the optimum wavelength for this particular sample. On this slide, we have the main system components of the endpoint detection system. First, we have the system controller box, which communicates with the PC over a standard USB cable. This box is available in the 19-inch rack mount size, as well as a smaller box if required. Then we have the detector head, which connects over a shielded detector cable to the control box, as well as the light source, which can be either contained in the main system controller, or in a separate housing, which would be then connected with another shielded cable to the box. Standard length cables are 2 meters, which can be extended to 10 meters or even longer than that if required by the customer. Currently, our manufacturing capability is 5 units per month. Our key long lead time components, mainly the printed circuit boards, are on stock for the next 8 units. All of our tools come with a standard 1-year warranty, which can be extended to 2 years if required, and the unit meets CE requirements. For more information, you can contact us at info@zebraoptical.com. Please feel free to send us any questions that you may have about this system.